The lesson topic for this video is Introduction to Probability. A couple of key vocabulary terms that we will need for this section are outcome and sample space. An outcome is one possible thing that can happen, and you know this word just from normal life. When people talk about the outcome of a basketball game that was played, who won, what was the outcome? Well, Osseo won, or whatever the case is. The sample space is a list of all possible outcomes. Sometimes we ask how many items will there be in the sample space, then I would just need a number. But if I ask for the sample space, I'm looking for a list of all the different possible outcomes. So for a quick example, this says in the final round of the playoffs before Super Bowl 50, the Broncos, Patriots, Cardinals, and Panthers remain. So what is our sample space? Again, in this case, you need to write out a list of all the possible outcomes. Well, the Broncos might win. The Patriots might win. The Cardinals. Or the Panthers. And again, they were all just listed in this case right here, and that's not always going to be the situation. What is one outcome for the Super Bowl? Well, one outcome would be the Panthers are going to win. That is one possible outcome. So, sample space is all the possible outcomes listed, and an outcome is one of those possible outcomes. Okay, so on this set of examples, I would like us to list the sample space. So, flip one coin. Well, there's heads and there's tails. And I'm abbreviating with an H and a T because I think we would all understand that. But what if we were to flip two coins? Well, the first coin could be heads, and the second coin could also be heads. Or the first coin could be heads, and the second coin could be tails. Or the first coin could have been tails, and the second coin heads, or they both could have been tails. A 4-section spinner contains red, green, yellow, and blue. What if we spun this spinner just one time? Well, the options are red, green, yellow, or blue. But if we spin it 2 times, our sample space is going to become much larger. Again, keeping organized when listing the sample space would be important. So I'm going to start with red. And I'm going to say, let's say my first spin was red. Well, what could follow? Well, red could follow again, or green could follow, right? Or I could spin red and then yellow, or I could spin red and then blue. That would be if I spun red first. Well, what if I spun green first? Well, green and then red, or green and then green again, or green and then yellow, or green and then blue. And we can continue this chart with yellow being first, or lastly, and I'm running out of space here, I'm going to just move my spinner here, or not. There we go. Or I could have spun blue first. So blue and then red. Sorry, I'm trying to stay organized. Blue and then red. Or blue and then green. Blue and then yellow. Or I could have spun blue twice. Okay, so if we take a look at this example, it says if you flip a coin and then roll a 6-sided die, how many outcomes are there? Sometimes I'll actually ask you to list out the sample space, and sometimes I'm just asking for how many items there would be in the sample space, or in other words, how many outcomes are there. The fundamental counting principle is a quick way to find that answer. The fundamental counting principle is the idea that if we have A ways of doing something, so flipping a coin, we would have 2 ways of doing that, and B ways of doing another thing. So rolling a die, we would have 6 different ways of or outcomes for rolling a die. Then there are A times B ways of performing both actions. So again, this is one way we can find the total number of outcomes. A lot of times I will think of the fundamental counting principle as thinking about, okay, here's our first result of something that happened. So in other words, the first result for flipping the coin. And then we have a second thing that happens, which would be rolling the die. And again, we need to multiply the number of options for each, or the number of outcomes for each. So, how many outcomes are there for flipping a coin? Well, there's 2, heads or tails. How many outcomes are there for rolling a die? Well, 6. There's 1, 2, 3, 4, 5, and 6. So, all we need to do is multiply 2 times 6 and we get 12. There are 12 ways or outcomes for this situation. Again, if we wanted to list out the sample space, we could. We could say there's heads and 1, or there's heads and 2, heads and 3, heads and 4, 5, 6, or we might have got tails on the coin, and again there's tails and 1, tails 2, tails 3, 4, 5, and 6. As you can see, there are 12 outcomes in this sample space, which we found using the the fundamental counting principle. I stumbled over that word because sometimes it is called the multiplication counting principle as well. Okay, in these examples, we're going to use that fundamental counting principle to help us determine the number of outcomes in our sample space. So, this first set of examples says there's an 8-section spinner containing the numbers 1 through 8. So if we wanted to visualize, this is a spinner with 8 different sections, and they'd be numbered 1 through 8 to just help us visualize the situation. Alright, so if we're going to spin one time, well, that's just one spin. How many different outcomes are there? Well, there would be 8, and that would be it. If we were going to spin it 2 times, how many different outcomes would there be? Well, I'm going to spin the first time, there are 8 possible outcomes. I'm going to spin again, there are 8 possible outcomes again, because I could get the same number again, and 8 times 8 is 64. And if I was going to spin it 4 times, for the first spin I have 8 possible outcomes, the second spin I have 8 possible outcomes, the third spin 8, and the fourth spin 8 again. So we'd need to multiply 8 times 8 times 8 times 8, which is 4,096 possible outcomes. This next question is unrelated to the spinner. It just says 6 cars drive into a lot with 6 parking spots. Well, if we can visualize the 6 parking spots like so, this problem is actually a little bit different than the previous problem. Notice that in the previous problem, after I spun one time, let's say I spun and I got a 4, the next spin I still had 8 outcomes because I could have spun the 4 again. In this situation, however, 6 cars are driving into a lot, so one at a time. How many cars could park into this space right here? Well, 6. But after that car is parked, how many different cars could park here? Well, 5. And then how many here? 4, and then 3, and then 2, and then the last car only has one option, and it is that last spot that remains. So in this situation, we're going to multiply 6 times 5 times 4 times 3 times 2 times 1 to find out how many different outcomes there are. In this case, that is 720 possible ways those 6 cars can park in those 6 spots. That is another way that the fundamental counting principle is used. Okay, so the topic of this lesson, this video, is probability, and we haven't talked about probability yet. So here is the definition of probability, and you guys have used probability before, so this is not brand new to you. It's the ratio of favorable cases to the whole number of cases possible. In other words, the probability of A happening, something, here, we'll just call it A, is the number of successes, or the outcomes that we are counting, divided by the total number of outcomes in the entire sample space. So again, you can see where that practice with outcomes in sample space is needed. We'll look at some examples on the next slide, but first I just want to remind you that probability will always be a value between 0 and 1. And it can include 0 and 1. I shouldn't say just between, but it can include 0 and 1 as well. What does 0 mean in probability? If I said that the probability of something happening is 0, it means that it is impossible. Okay, so if I said, what is the probability that you are going to have a math test on February 31st? Well, that's impossible. There is no February 31st. So 0 chances. A 1, on the other hand, means that it is certain to happen. Certain. So if I said, what is the probability that a random month picked out of a year has at least 20 days, well, every month has at least 20 days, so that would be certain. So 0 is impossible, 1 is certain, and everything in between is the rest of our probability options. Okay, so just a quick set of practice problems on finding probability. It says you have a 10-section spinner. Find the probability of each. Now, before you begin a probability problem, I always suggest you think about this question right here. How many total outcomes are there? Well, you're spinning a 10-section spinner. Sounds like you're only going to spin it once. It doesn't say anything about spinning it more than one time. So how many total outcomes are there? Well, of course, since it's a 10-section spinner, got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10 possible outcomes. That number will always, in this case, be the denominator of your fraction for probability because it is the total number of possible outcomes. So if you think back to the previous slide, probability is the number of successes or ways to count the outcomes of things that you want. And what I mean by want is get what the question is asking about, divided by the total number of possible outcomes. Okay, so landing on an even number. Well, in a 10-section spinner, there are 5 even numbers because 2, 4, 6, 8, and 10. 5 even numbers, and again, that is divided by the total number of possible outcomes, which is 10. So the probability of landing on an even is 5 over 10, or that reduces to 1 over 2, which we know as 0.5. So, and that's also known as 50%. How about landing on a factor of 12? Well, our factors of 12, any factors of 12 are 1, 2, 3, 4, 5 is not, 6, 7, and 8, 9, 10, 11 are not, but 12 is. But 12 is not on our spinner, so we can't count that. So the number of factors of 12 that we could land on the spinner is 1, 2, 3, 4, 5. 5 possible ways to get to land on a factor of 12 out of 10. Again, 1/2 or 0.5. How about landing on a number that is less than 7? Be careful on these. Less than 7 does not say less than or equal to 7, just less than. Well, the numbers that are less than 7 are 1, 2, 3, 4, 5, and 6 on our spinner. That's 6 options out of 10 total number of possible outcomes for the spinner, which is 0.6. Sorry, I'm rushing through this last set, but we are running out of time on this video. So, more practice for sure in class.